Hello viewers, in today's session we are going to discuss another important problem from derivatives, and in this session we are going to discuss this problem in which we are given a function y that is equal to integral 0 to x e raised to 2 times mod of t minus 1 dt, and we have to find the derivative of y with respect to x at x is equal to minus 2, right? So here to solve this problem we'll make use of Leibniz integral rule. So let us start. So Leibniz integral rule says that if we have an integral uh, in which the lower limit and the upper limit are functions of x, so let us take the lower limit as u of x and upper limit as v of x. And here we have a function, say f of t dt, and suppose we want to differentiate this integral with respect to x, right? So the derivative of this definite integral with respect to x is given by f of v of x. So first we'll replace this t by the upper limit, that is v of x, and then we multiply this quantity by the derivative of v of x, that is v prime of x. Then here we have a negative sign, then we replace this t by u of x, so we have f of u of x, and then we differentiate u of x with respect to x. So this is the Leibniz integral rule when we have here a function of t only, right? So let us make use of this result to differentiate this function y. So we can now write dy over dx is equal to d by dx of the integral 0 to x, and here and the function is e raised to 2 times mod of t minus 1, and here we have dt. So now if we compare this integral with this one, then we can see that the lower limit, that is u of x, is 0, and the upper limit v of x is equal to x, right? And the function f of t is given by e raised to 2 times the absolute value of t minus 1. So now we can write here f of v of x. So we have here e raised to 2 times mod of t minus 1. So we'll replace this t by x. So we have x minus 1, and then we differentiate x with respect to x. So here we have d by dx of x. Then here we have the negative sign. Then we have f of u of x. Now here we have u of x is equal to 0. So we can now write e raised to 2 times the absolute value of 0 minus 1, because we now replace this t by 0, and then we differentiate u of x with respect to x. So here the lower limit, that is u of x, is 0. So here we have d by dx of 0. So now this quantity is equal to 0 because here we have 0. So now we have simply e raised to 2 times mod of x minus 1, and the derivative of x with respect to x is 1. So we are now left with e raised to 2 times mod of x minus 1. So now the derivative of this function y, that is dy over dx, is given by this quantity. So we can write dy over dx is equal to e raised to 2 times mod of x minus 1. Now let us apply the definition of mod function here. We know that mod of p is equal to positive p whenever p is greater than 0. Mod of p is 0 when p is equal to 0, and mod of p is equal to negative p when p is less than 0. So here we have mod of x minus 1, and mod of x minus 1 is positive x minus 1 whenever x minus 1 is greater than 0 or x is greater than 1, and mod of x minus 1 is 0 when x minus 1 is equal to 0. This implies x is equal to 1, and here mod of x minus 1 is equal to negative x minus 1 when x minus 1 is less than 0, that is x is less than 1. Right, now see here we have to find out the derivative of y with respect to x at this point. X is equal to minus 2. So now this point x is equal to minus 2 is less than 1, right? So we have to make use of this definition of mod of x minus 1. Mod of x minus 1 is negative of x minus 1 when x is less than 1, and minus 2 is less than 1. So here we can now write e raised to 2 times, and here we have a negative of x minus 1. So replacing mod of x minus 1 by negative of x minus 1, so we have e raised to 2, and here we have now minus x plus 1. So we can now write e raised to minus 2x plus 2, right? And now taking x is equal to minus 2, and the required derivative of y with respect to x is given by substituting x is equal to minus 2 in this expression. So we have minus 2, and here we have minus 2 plus 2. So this is e raised to 4 plus 2, that is e raised to 6. So this is the required value of the derivative of y with respect to x at x is equal to minus 2, and the value is e raised to 6, where e is the exponential number.